Welcome to week 3, lesson 13. In this lesson, we will take over an hour breaking down all of the information we have learned about decimals and integers. I am Ms. V. Richardson, and I will be your instructor for the course. Grab your guided notes, and let's jump right into the lesson. Decimals and integers review. In this lesson, we are going to practice adding and subtracting decimals. Now, we need to remember here to line up the decimals and drop that decimal straight down as we're working through these problems. So let's begin. We have 22 and 4/10, and we are adding that to 8 and 14/10. Remember, the first thing we want to do is line up that decimal point. Now here, we're also going to annex in zeros just to make sure that everything has a space, and we're going to add based on the columns. 0 plus 4 is 4. 4 plus 1 is 5. We remember to drop that decimal point straight down. 2 plus 8 is 10, so let's carry that 1 plus 1 up there, and then 1 plus 2 is 3. So our answer here is 34 and 54 hundredths. In this next problem, we are adding a positive number and a negative number. So we remember when we're adding these two different numbers, it depends on which value is larger. So when we compare our positive and our negative, we have 10 positives approximately and 3 negatives. That means we have more positives than we have negatives, so our answer will be positive. Now we're going to write 10 and 1/10 plus a negative 3 6/10. So because we have more positives than we have negatives, we are going to turn this into a subtraction, and remember that our answer is going to be positive. 1 minus 6. Well, we know we cannot do that, so we have to borrow from the 10 and make that 9, and that turns our 1 now into 11 because we added 10 to it. So 11 minus 6 is 5. We remember to bring that decimal point straight down. And 9 minus 3 is 6. So our answer in this problem is 6 and 5/10. Next, we have a negative number added to a positive number. So these two are different. We are going to have to compare them. When we're comparing our negative and our positive, we have approximately 28 negatives and 25 positives. That means our negatives are greater in quantity than our positives, so our answer is going to be negative. Now here we're going to take this negative 28 and 28 hundredths, and we're going to add to that 25 and 32 hundredths, remembering to line up that decimal. Now for this problem, because we know they're going to be different and we know that our answer is going to be more negative, we are going to subtract these two. All right, so let's continue. 8 minus 2 is 6. 2 minus 3 cannot be done, so we need to borrow. We're going to change that 8 into a 7, and that 2 now is going to become a 12. So we have 12 minus 3, which is 9, and we remember to bring that decimal point straight down. 7 minus 5 is 2. And 2 minus 2 is 0. So don't forget on this problem, our answer is going to be negative. So negative 28 and 28 hundredths plus 25 and 32 hundredths still gives us a negative value of 2 and 96 hundredths. Do not forget that even though we're dealing with decimals, we still have to pay attention to the negatives and positives. In this last problem, we have a negative plus a negative. Now we know that when we have these same signs, we are going to get a negative answer. It just makes it more negative. So we have negative 1 and 4/10 plus negative 2 and 8/10. And we are going to add those. 4 plus 8 is 12. We bring down our 2. We carry our 1. Do not forget to drop that decimal point straight down. Drop that decimal point straight down. Lastly, we're going to add 1 plus 1 plus 2, which gives us a value of 4. Now remember, this is a negative plus a negative, so our answer will be negative. And our answer is 4 and 2/10, and this value is negative. We have 7 and 1/10 minus 2 and 2/10. Now we can see here we have a positive minus a positive. Now our first positive is much larger than our second, so here our answer is still going to be positive. We are not taking away enough to put that into the negative category. But we do have to borrow, however, because 1 minus 2 cannot be done. So we're going to borrow from that 7 and make it 6. And that's going to change our 1 to an 11. Now we have 11 minus 2, which is 9. Now do not forget to bring that decimal point straight down. 6 minus 2 is our next problem, and that answer is 4. So that gives us 4 and 9/10 as that answer. We have a positive number minus a negative number. Now remember, when we have minus negative, we are going to do our keep, change, flip to correct this problem because we like to add our problems together. So that means we get a value of 13 and 45/100. Change that subtraction to an addition. Flip that negative number to a positive number. So that is now a positive 3. Now we're going to annex the rest of our zeros in just to make our problem easier to read and lined up properly. And we're going to add these two values. We have 5 plus 0 equals to 5. 4 plus 0 is equal to 4. We remember to bring our decimal point straight down. 3 plus 3 is equal to 6, and 1 is being brought straight down. So our answer here is 16 and 45/100. In this next problem, we have a negative minus a positive number. Now remember, we like to add, so again we are going to do our keep, change, flip to make this problem much more simple for us. Now looking at this problem, we have negative 11 and 4/10. Change that subtraction to an addition, and this 18 and 55/100 is going to be flipped. So instead of that being a positive 18 and 55/100, now it is a negative 18 and 55/100. So we remember a negative plus a negative is only more negative. Let's annex in our zeros and work through this problem. We have negative plus a negative, which will give us a more negative answer. 0 plus 5 is 5. 4 plus 5 is 9. We remember to bring that decimal point straight down. Next, we have 1 plus 8 is 9, and 1 plus 1 is 2. So a negative plus a negative is more negative. Our answer is negative 29 and 95/100. Lastly, we have a negative number again minus a negative number this time. So we're going to go through the same process and remember to do keep, change, flip. We're going to keep our first number, which is negative 7 and 45/100. We are going to change that subtraction sign to an addition sign, and we're going to flip this negative 7 and 21/100 to a positive 7 and 21 hundredths. Now here we have different values. We have a negative and a positive. So if we're comparing these, because they are different, we can see that we have more negatives than we do positives. That means our answer is going to be negative when we subtract these. Because they are different, we need to find the difference between those, and we know that our answer is going to be negative. We have 5 minus 1, which is 4. We have 4 minus 2, which is 2. We remember to bring that decimal point straight down, and then we have 7 minus 7, which is 0. Now this problem is going to be negative because we had more negatives than we had positives, and the final answer is negative 24 hundredths. Let's continue our review by multiplying decimals. Remember, when we are multiplying decimals, we want to count the decimals out of the factors and then to count them back into the product. So let's remind ourselves what that means, and let's start by looking at this first problem, 19 and 1/10 times 8 and 7/10. So the first thing we do is we're going to count that decimal out to the right. Now here I'm moving one space out, and here I'm moving one space out to get that decimal out to the right. We know that 1 plus 1 is equal to 2, so we have moved 2 spaces out. Now looking at these values, we remember that a positive value times a positive value is going to give us a positive answer. Same sign is positive. Now we're going to work this out as if these were whole numbers. So we have 191 times 87 because we moved those decimals out. Now let's start with the 7. 7 times 1 is 7. 7 times 9 is 63. So we're going to write the 3, and we're going to write plus 6 here at the top. 7 times 1 is 7, plus 6 is 13. So 191 times 7 is 1,337. Now we're going to move over to the 8, but before we do, we have to remember to add our 0. Now we have 8 times 1, which is 8. 8 times 9, which is 72. So I'm going to write my 2 here, and then I'm going to write plus 7. So this time we're going to be adding 7. 8 times 1 is 8, plus 7 is 15. So this value of 191 times 80 is 15,280. Now we want to add those two values together to get our final answer. And we have 7 plus 0 is 7. 3 plus 8 is 11. So carry our 1 here. 1 plus 3 plus 2 is 6. 1 plus 5 is 6, and we're just going to bring that 1 down. So here we had 16,617. But remember, we moved out 2 spaces, so we have to move that decimal back in 2 spaces. So we're back here on the right. We're going to move it over 2 spaces. That means our final answer is 166 and 17 hundredths. Let's continue on with our next problem. We have a positive number times a negative number. Now we remember our rules of integers. When we are multiplying different signs, our answer is going to be negative. So a positive times a negative is a negative. Let's count our decimals out to continue. We're going to move out 2 spaces in this factor, and we're just going to move 1 single space in that factor. So 2 plus 1 is equal to 3. We moved out a total of 3 spaces. We're going to have to move back in a total of 3 spaces. This problem is 4,555 now times a negative 12 because we moved that decimal out. So let's work through these problems, and let's start with this 2 here. 2 times 5 is 10, carry the 1. 2 times 5 is 10 plus 1, which is 11, carry the 1. 2 times 5 is 10 plus 1, which is 11, carry the 1, plus 1. 2 times 4 is 8, plus 1 is 9. So 4,555 times 2 is 9,110. Now we are going to annex in our 0 so that we can move over to our next value, which is 1. 1 times 5 is 5. 1 times 5 is 5. 1 times 5 is 5. 1 times 4 is 4. Now we add these two values together. 0 plus 0 is 0. 1 plus 5 is 6. 1 plus 5 is 6. 9 plus 5 is 14. So let's carry that 1. And 1 plus 4 is 5. So here we have 54,660. And we remember that we moved our decimal out 3 spaces. So we have to move it back in 3 spaces when we get to our product. 1, 2, 3. That means our decimal point goes in between the 4 and the 6. And our final answer is negative 54 and 66 hundredths. Next, we have a negative times a positive, and we remember that when our signs are different, that is going to give us a negative answer. To move out the decimals now, let's count those out. 1, 2, 3 spaces here, and simply 1 space there. So 3 plus 1 is equal to 4. That means we moved our decimal out 4 spaces. Now we're going to multiply these as if they were simply whole numbers. We have negative 9,123 times a positive 44 because we moved those decimals out. So let's start with our first 4 here. 4 times 3 is 12, carry the 1. 4 times 2 is 8, plus 1 is 9. 4 times 1 is 4. 4 times 9 is 36. Now we annex in a 0 so that we can work with the next 4. 4 times 3 is 12, plus 1. 4 times 2 is 8, plus 1 is 9. 4 times 1 is 4. 4 times 9 is 36. Now let's add those two together to get a total answer. 0 plus 2 is 2. 9 plus 2 is 11. Carry the 1, so plus 1. 1 plus 4 plus 9 is 14. So we're going to carry that 1 plus 1. 1 plus 6 plus 4 is 11. Carry the 1 plus 1. 1 plus 3 plus 6 is 10. Carry the 1 plus 1. 1 plus 3 is 4. So that gives us a total of 401412. Now we remember that we moved 4 spaces out, so we have to move 4 spaces in back to the product. 1, 2, 3, 4. So now our decimal falls in between the 0 and the 1, and that gives us a total of negative 40 and 1,412 10,000ths. In this next problem, we have a negative times a negative, and we know that that is going to give us a positive answer. So for our first factor, we do not have to move the decimal out, but in our second factor, we have to move that decimal over 1 space. So a total of 1 space that we're moving out. Now we're going to write the whole numbers, which will be 20 times 38 because we moved that decimal out. So let's start with our multiplication and begin with our 8. 8 times 0 is 0. 2 times 8 is 16. Now we're going to annex in a 0 and continue with our 3. 3 times 0 is 0. 3 times 2 is 6. Our next step is to add these two together and give us a total. 0 plus 0 is 0. 6 plus 0 is 6. 1 plus 6 is 7. Now remember, because we moved that decimal out one space, we have to move it back in one space between the 6 and the 0. So our final answer is a positive 76.0, or just 76. In this next section, our goal is to divide decimals. Remember, count out the decimal in the divisor and pop straight up from the dividend. Here we have 109 and 71 hundredths divided by 7 and 74 hundredths. So we write the 109 and 71 hundredths inside divided by the 7 and 74 hundredths on the outside. First, we move that decimal 2 spaces to the right. 1, 2. This is moving the decimal from our divisor, and this will give us the value of 774. Now we move the decimal 2 spaces in our dividend and pop it straight up. 1, 2, straight up and out. That gives us a new value of 10,971 with the decimal at the end. Let's ask ourselves a series of questions to see how many times we can take out 774. So if we have 1, can we take out 774? No. If we have 10, can we remove 774? No. If we have 109, can we remove 774? No. If we have 1097, can we remove 774? That answer is yes. How many times can we take out 774? That is 1 time. 1 times 4 is 4. 1 times 7 is 7. And 1 times 7 is 7. So we're going to subtract that away. And 7 minus 4 is 3. 9 minus 7 is 2, and 10 minus 7 is 3. So that leaves us with 323. Is that enough to take away 774? No. So we have to drop that 1 down, and that'll give us 3,231. Now, can we take 774 from that? Yes, we can. We can do that 4 times. 4 times 4 is 16, so we're going to carry that 1 plus 1. 4 times 7 is 28, plus 1 is 29. So we're going to write our 9 and carry our 2, plus 2. 4 times 7 is 28, plus 2 is 30. Now we're going to subtract those. As we begin subtracting, we realize that we cannot take 1 from 6, so we have to borrow from the 3. When we borrow from the 3, we make that 2, and our 1 now becomes 11. So 11 minus 6 is 5. Now we have 2 minus 9, but we cannot do that either, so we have to borrow from the 2 and make that 1, which turns our 2 into a 12. 12 minus 9 is 3. Now we have 1 minus 0, and 1 minus 0 is 1. And 3 minus 3 is 0. So we have 135 left. We cannot take 774 from that. So that means that we're going to have to add another 0 and drop that down. Once we add another 0, we have 1,350. And can we take 774 from that? Yes, we can 1 time, and that will be 774. Now we have to subtract those two. Well, being that we have 0 minus 4, we cannot do that, so we have to borrow from the 5 and turn that 5 into a 4. That 4 turns our 0 into a 10. So now we have 10 minus 4, and 10 minus 4 is 6. We cannot do 4 minus 7, so we have to borrow again from the 3. We will turn that into a 2, and that 4 now becomes 14. 14 minus 7 is 7. and we have 12 essentially minus 7. So let's look at that as a full 12 instead of just a 2. 12 minus 7 is 5. So now that we have 576, we know that we cannot take 774 away from that, so our answer continues. We're going to stop this problem here just so that we don't draw it out too long. The answer to this problem is approximately 14 and 1/10. As we continue this next problem, please make sure to pause the video and write down everything that you need to. Now, in this next problem, we have 36 as our divisor, and it is a whole number, and we are dividing that by -6 and 36/100ths. Remember, for this problem, a positive divided by a negative gives us a negative answer. Let's start by looking at the divisor and noticing that there are 2 decimal spaces that we'll need to move out. 1, 2. So because we moved them out of the divisor, we have to move them out of the dividend. That means we need to extend our line and add our decimal point, add 2 zeros in, and then move that decimal space out 1, 2 spaces before we pop it up and out above our line. This now gives us a value of 636 divided into 3,600. Our decimal is on top to the right of our last zero, and now we're going to start asking ourselves questions. If we have 3, can we take away 636? No, we cannot. If we have 36, can we take away 636? No. What if we have 360? Can we take away 636? No, we cannot. We can only do that if we have 3,600. That way we can take away 636 5 times. 5 times 636 is 3,180, and we're going to subtract those very simply. 0 minus 0 is 0. We cannot take 8 from 0, so we have to borrow from the 6. We're going to turn that 6 into a 5 and our 0 into a 10. 10 minus 8 is 2. 5 minus 1 is 4, and 3 minus 3 is 0. So we are left with 420 that we cannot take 636 from. Next, we want to annex in a 0 and drop that down to give us a total of 4,200. Now, we have to ask ourselves, if we have 4, can we take 636 from that? No, we cannot. If we have 42, can we take 636 from that? No, we cannot. What if we have 420? Can we take 636 from that? No, we can only take 646 away from 4,200. We can subtract 636 away from 4,200 a total of 6 times. 6 times 636 is 3,816. Now we're going to subtract those. Looking at this problem, I know that I cannot take the 1 nor the 6 away from 0, so I'm going to borrow from the 2 and turn that into a 1. That's going to change my 0 to a 10, which I am now going to change to a 9 so that I can share with my last 0. So when I borrow from that 10, that'll leave me with 9 and turn my last 0 into a 10. From there, I can easily subtract. 10 minus 6 is 4. 9 minus 1 is 8, and 41 minus 38 is 3. Now we can continue this problem by adding more zeros, but we are going to stop here and look at our answer as approximately 5 6/10. Do not forget the rules of integers. A positive divided by a negative is always a negative answer. So the answer to this problem is approximately 5 6/10, but that answer is negative. So it is a negative 5 6/10. Before we continue on to the next problem, make sure that you have everything written down. Now, looking at this problem, we remember that a negative divided by a positive is going to give us a negative answer. Our first value is a negative whole number, so we're just going to write that out as a positive value, 1,478. And that value is going to be divided by 156 6/10. Now looking at our divisor, we see that we can move that decimal place over one space. So we're going to move that over 1. And for our dividend, we need to extend our line. We need to add a decimal and add a 0 in order to move that decimal over one space. Now we're going to pop it straight up and out of our problem. Now that we have moved that decimal over and out, we can rewrite our problem to give us 1,566 divided into 14,780. And that decimal point is going to sit right there behind that last 0 at the top of the problem. Now we begin with the division. If we have 1,566, can we take that from 14,780? So let's start. If we have 1, no. 14, no. 147, no. 1,478, no. But if we have 14,780, we can take out 1,566 9 times. 9 times 1,566 is 14,094. So we are going to now subtract those. In our first column, we cannot take 4 from 0, so we have to borrow from the 8 and make that 7, which makes our 0 a 10. So 10 minus 4 is 6. We cannot take 9 from 7, so we have to borrow again, and we're going to turn that 7 into a 6 and turn our 7 into a 17. So 17 minus 9 is 8. Now we have 6 minus 0, that is 6, and 14 minus 14 is 0. Now if we have a 6, can we take away 1,566? No, we cannot. If we have 68, can we? No, we cannot. If we have 686, can we take away 1,566? No, we cannot. So we have to add in another 0 and drop that down. Once we add that in, that will give us a value of 6,860, and we can definitely take 1,566 from that 4 times. 4 times 1,566 is 6,264, and the last thing that we're going to do is subtract these two values. Because we cannot take 4 from 0, we have to borrow from the 6 and make that 5, which makes our 0 a 10. So now we have 10 minus 4, which is equal to 6. Now we can't take 6 from 5, so we have to borrow again. We're going to borrow from that 8 and turn that 8 into a 7, which turns our 5 into a 15. Now we have 15 minus 6, and 15 minus 6 is 9. 7 minus 2 is 5, and 6 minus 6 is 0. So as we keep adding zeros, our problem can continue on, but we're going to stop right here and share that our answer is approximately negative 9 and 4/10. Please pause the video to make sure you have everything that you need written down. Now in this next problem, we see that we have a negative divided by a negative. We know when the signs are the same, that is going to give us a positive answers, and those are the rules to our integers. We have negative 12 and 74 thousandths being divided by a negative 3. So we're just going to write 3 here. Now we can see with this 3 that we do not have a decimal to move, so that means we're just going to pop that decimal straight up in our dividend as well. Our new problem is going to be 3 divided into 12,074. We make sure to put our decimal in between our 2 and our 0 above our dividing line, and let's ask ourselves questions now. If we have 1, can we take 3 away? No, but if we have 12, we can take 3 away 4 times. 4 times 3 is 12, and we simply subtract those and get a value of 0. Now, as we continue this problem, we bring our next 0 down. So we're asking ourselves here, if we have 0, can we take 3 away? And that answer is no, but we are going to give a place value and make sure to add another 0. So 0 times 3 is 0, and when we subtract those, we get another value of 0. From here, we are going to bring our 7 down. So now we're asking ourselves, if we have 7, can we take 3 from that? And we can do that 2 times. 2 times 3 is 6, and we subtract that. 7 minus 6 is 1. Next, we bring our 4 down, and that gives us a total value of 14. Now, if we have 14, are we able to take 3 away? That answer is yes, we can take 3 away from 14 4 times. 4 times 3 is 12, and when we subtract that, we can see that our problem can continue going and going, especially as we continue adding zeros, but we're going to stop here and approximate the answer to our problem. The answer is approximately a positive 4 and 24 thousandths. In this section, we are going to practice comparing and ordering integers on a number line and using models. Let's look at this first problem. -2 compared to +7. We can easily add these numbers to the number line below. Here we have a -2, and here between the 6 and the 8, we have a +7. -2 is to the left of 0, and +7 is to the right of 0. So we always remember that left is less, and our number line moves from least to greatest from left to right. Now let's grab our integer models. If you did not print these out, feel free to write your models into your guided notes using pluses and minuses. For -2, I'm adding 2 minus signs, and for +7, I'm adding 7 plus signs. We know that there is a greater number of positives, and because 7 has more, we can say that 7 is greater than -2, and -2 is less than 7. Let's order a few integers on the number line next. Here we have some positive and negative integers. Do not forget that negative integers are to the left of 0 and positive integers are to the right of 0. Positive 4 is to the right of 0, -5 is to the left of 0, 8 is to the right of 0, -13 is to the left of 0, and +7 is to the right. So looking at our number line, we can see the numbers are listed in order from least to greatest. Our least number is -13, followed by -5, +4, +7, and +8, with +8 being our greatest value. Now grab your models again and let's show the positives and negatives for each integer. -13 should have 13 negative or minus signs. -5 has 5 negative or minus signs. 4 has 4 positive or plus signs. 7 has 7 positive signs. And 8, our greatest value, has 8 positive signs. We remember the greatest number is on the right and has the most positives. The least number is on the left. Left is less. Adding integers. +15 plus a -3. The first step is to look at the absolute value of each integer to compare our integers. The absolute value of 15 is 15, and the absolute value of -3 is 3. When our integers have different signs, the integer with the greater absolute value will share the same sign as the answer. We have more positives. So when we find the difference of the integers, the answer will be positive. 15 minus 3 is 12. -3 plus -8 means that we are working with the same sign. We only have negatives in our addition problem, so the answer will be negative. 3 plus 8 is 11, and because a negative plus a negative is a negative, this answer will be -11. Next up, we have a positive 7 plus a positive 11. A positive plus a positive is only more positive. 7 plus 11 is 18. This is a positive answer. Next, we have a negative 8 plus a positive 3, so we have to look at the absolute value of each of these integers to compare and determine which value has more. Do we have more positives or do we have more negatives? The absolute value of negative 8 is 8, and the absolute value of 3 is 3. So in this case, we have more negatives. And after finding the difference, we know that our answer will be negative. Negative 8 plus 3 is negative 5. Subtracting integers. Negative 9 minus a negative 12. We prefer to add integers so we can use keep, change, flip to transform this subtraction problem into an addition problem. We keep the negative 9 the same, negative 9. We change the subtraction problem to an addition problem, plus sign, and we flip that negative 12 to a positive 12. Now we have a negative number plus a positive number. Now that our problem is the addition of two different signs, we have to compare the absolute values. The absolute value of negative 9 is 9. The absolute value of 12 is 12. We have more positives in this problem. So the final answer after we subtract these two numbers will be a positive answer. 12 minus 9 is a positive 3. Here we have a negative number minus a positive number, negative 8 minus 3. We love to add integers, so we use keep, change, flip to keep that negative 8 the same, change the subtraction to an addition sign, and flip that positive 3 to a negative 3. These integers now have the same sign. A negative plus a negative is more negative. Next, we simply add the values together and keep the negative sign. Negative 8 plus negative 3 is negative 11. Here we have a positive minus a positive. This is something you should easily know, but let's prove that keep, change, flip works with all subtraction of integers problems. Let's keep the 9 and change that subtraction to an addition and flip that positive 6 to a negative 6. Comparing the absolute values, we have 9 versus the absolute value of negative 6 to give us a value of 6. So we can see here that we have more positives. Next, we just find the difference of the absolute values to give us a positive answer. 9 plus negative 6 is a positive 3. Next, we have negative 5 minus a positive 4. Let's change this to an addition problem by using keep, change, flip. Keep the negative 5 the same, change the subtraction problem to an addition problem, and flip that positive 4 to a negative 4. Now we have negative 5 plus negative 4. A negative plus a negative is more negative, so let's add the values together and keep the negative sign. Negative 5 plus negative 4 is equal to negative 9. Pause the video and make sure that you have everything written down in your guided notes. Multiplying integers. The easiest rule to remember is that the same sign is positive while different signs are negative. Let's begin with a positive 4 times a positive 6. Same signs are positive. 4 times 6 equals 24. In this next problem, we have a positive times a negative, and these signs are different, so they are going to give us a negative value. 4 times negative 8 is negative 32. In the next problem, we have a negative times a positive, so again, our signs are different. They will give us a negative answer. Negative 7 times positive 3 is a negative 21. In this last problem, we have a negative times a negative, and these signs are the same, so they will give us a positive answer. Negative 2 times negative 5 is equal to a positive 10. Now remember to pause the video to make sure that you have everything written down. Dividing integers follows the same rules as multiplying integers. The same sign is positive. Different signs are negative. In 36 divided by 12, we have a positive divided by a positive. Same sign is positive. 36 divided by 12 is 3. Negative 42 divided by a negative 3 gives us a positive answer because the same sign is positive. Negative 42 divided by negative 3 is positive 14. Remember, when you multiply integers with the same sign, you get a positive answer. Positive 64 divided by a negative 4 are different signs and will give us a negative answer. 64 divided by negative 4 is equal to negative 16. Negative 195 divided by a positive 13 will give a negative answer. Different signs are negative. Negative 195 divided by 13 is negative 15. Remember, when you multiply integers with different signs, you will get a negative answer. The most common way to remember how to solve order of operations problems is PEMDAS, parentheses, exponents, multiplication and division from left to right, and addition and subtraction from left to right. Or you can use GYMDAS, use grouping symbols first, then exponents, then multiplication and division from left to right, and then addition and subtraction from left to right. Looking at the first problem, we can find the innermost grouping symbol, the parentheses. This has 98 plus 2. This is the first problem we do. 98 plus 2 is 100. We write that directly beneath our problem and we bring everything else down. Don't forget to include any additional grouping symbols. Now for the second step, we continue with the innermost grouping symbol, and that would be the 100 we solved in step 1 divided by 10. We write that in and bring everything else down. 100 divided by 10 is 10, and we bring down the 100, the division, the subtraction, 100 plus 121. Now for the third step, we have no grouping symbols left, and I do not see any exponents. Let's label our operations. We have a division, a subtraction, and an addition. So the first thing we want to do is take care of that division. 100 divided by 10 is 10. And we remember to bring everything else down in our third step. Lastly, we have addition and subtraction from left to right. So in our problem, subtraction is on the left, and we do that first. 10 minus 100 is negative 90. We remember to bring everything else down. Addition is our last step, so negative 90 plus 121 is 31. We have more positives than we have negatives, so this answer is a positive 31. Draw out the stair step to help you remember to check off all of the steps to solving order of operations problems. In this next problem, we look for the innermost parentheses or grouping symbols. The first step is to complete the 7 plus 3, which is 10. Then we bring everything else down. For step number 2, the innermost grouping symbol contains 2 times 10. 2 times 10 is 20, and we remember now to bring everything else down. In step 3, we have another grouping symbol that contains 20 divided by 2, which is 10. We bring down everything else and we see that our final step is an addition problem, 66 plus 10, which is simply 76. Pause the video as you need to make sure that you have written everything down and labeled your problem with fun colors to help you remember. In this next problem, we will see that there are several operations within the parentheses. We always follow order of operations, so when we look inside, we have multiplication, an exponent, and an addition problem. The highest ranking operation in the parentheses is the exponent, so we do that first. The first step is 5 squared, which is 25. Then we bring everything else down. 7 plus, open parentheses, 6 times plus 3, close parentheses, minus 5. For step number 2, we are still in parentheses and the options are multiplication and addition. We do multiplication before we do addition, so this problem for step 2 is 6 times 25, which is 150. Then we bring down everything else in our problem. For the third step, we are still in the parentheses and the only operation that there is to use is the addition. So in step 3, we're going to do 150 plus 3, and that value is 153. Now we remember to bring everything else down. In step 4, we choose between an addition and a subtraction. Remember, we always do the one to the left first, and that is the addition. 7 plus 153 is 160, and we bring everything else down. Now the final step in our problem is subtraction, and that is 160 minus 5, which is 155. In this last problem, we have a parentheses with 4 plus 3 inside. 4 plus 3 is 7. Then we bring everything else down. There are no exponents, so now we're at multiplication and division. And remember, we do these problems from left to right. The multiplication problem is on the left, so we do that first. 18 times 7 is 126. Now we remember to bring everything else down. Next, we do division. Now we have 126 divided by 8. That equals 15 7/75. Next step, we bring everything down. Now we only have addition and subtraction remaining, so we do the addition first as it is on the left. 84 plus 15 7/75 is 99 7/75. Don't forget to bring down that minus 14, and that will be our last step in this problem. The last step is subtraction, and we do 99 7/75 minus 14, which gives us 85 7/75. If you need additional review, check out the Order of Operations Easiest Pi activity to extend your learning. Distributive property. When you have a factor that is being multiplied by the sum of numbers, you can share that factor with each number. We share by multiplication. So here we have A times the sum of B and C, which will give us A times B plus A times C. We always want to make sure to pay attention to the sign. Next, if we have a factor that is being multiplied by the difference of numbers, you can share that factor with each number just the same way, A times B minus A times C. Again, we just share with multiplication. Let's line up the first problem to the template of sharing the sum of two numbers and define each component of the problem. 13 will be A, 8 will be B, and 21/100 will represent our C. We have A times the sum of B and C, and we can share our factor of A to give us A times B plus A times C. Let's substitute our values in. 13 times 8 plus 13 times 2100. Let's try an example where we decompose the 8 and 600. 7 will be A, 8 will be B, and 600 will be C. We distribute the factor by the sum of two numbers that add up to 8 and 600. So we have A times B plus A times C. Now when we substitute in our numbers, we get 7 times 8 plus 7 times 600. If we have more than one operation in the parentheses, we share the factor with every element. We share 2 and 2500 with 99, and then we write a plus sign. Then we share 2 and 2500 with 23, and then we write the plus sign. Then lastly, we share 2 and 2500 with 5. Each element is multiplied by the factor. In the final problem, we can see that we are sharing 5 with 3 elements. Here we need to pay careful attention to the signs. We multiply 5 times 3.4 and we write a subtraction sign. Then we multiply 5 times 7 and 1/10 and we write an addition sign. Lastly, we multiply 5 times 10. Here we show 5 being shared with 3 and 4/10. Next, 5 being shared with 7 and 1/10, and notice the subtraction sign that is between them. Lastly, we have 5 being shared with 10. All of our sharing is by multiplication. Mean, median, mode, and range. Let's break down the values of these two data sets to find the mean, median, mode, and range. The first thing we do to find the mean is to add up all the numbers. So here we have 12 plus 15 plus 17 plus 12 plus 9 plus 13 plus 20 plus 11 plus 17 plus 16 plus 12. That gives us a total value of 154. Now, if we count the amount of numbers that we have 11. So that means we take that 154 and we divide it by 11 to give us a value of 14. 14 is our mean. Next, let's find the median by putting our numbers in order from least to greatest. So our lowest number is 9, then we have 11, then 12, then 12 again, 12 again, 13, 15, 17, 17 again, and 20. Finding the median is really simple because we're just looking for the middle number. So let's scratch out the lowest number, the highest number, the lowest, the highest, the lowest, the highest, the lowest, the highest, the lowest, the highest, and we can see that we're left with 13 in the middle. So 13 is our median number. Let's rewrite our numbers to find the mode. Now we remember that the mode is the number that we see most often. So after we write out all of our numbers, we're looking for the number that is there most often. As we're looking at this, we can see that we have 3 12s. So the mode in this problem is 12. Lastly, we want to find the range. Now the range is the highest value, which is 20, minus the lowest value, which is 9. 20 minus 9 is equal to 11. The range for this first data set is 11. Now let's take a look at this second data set. We started off just the same way because we want to find the mean of the data set. So the first thing we do is add up all of the numbers. 110 plus 90 plus 70 plus 30 plus 30 plus 40 plus 80 plus 70 plus 90 plus 90. That gives us a total value of 700. So now we count the amount of numbers that we have and we divide that 700 by that. We have 10 numbers and 700 divided by 10 is 70. The mean for this problem is 70. Next, we find the median by putting our numbers in order from least to greatest. Then we mark them off to find the middle number. We have two middle values here, so we have to find the mean of those values. We take 70 plus 80, and that gives us a total of 150. Then we divide it by 2 because we have two numbers, and that gives us a value of 75. So our median is 75. Now let's find the mode. We're going to rewrite the numbers again in order from least to greatest just to make sure that we have all of our numbers there. Now, when we write out our numbers, you want to make sure to include every single number. From here, we can see the number most often found is 90. So 90 is our mode. Lastly, we want to find the range, and that's taking the highest value, which is 110, and subtracting the lowest value. Our lowest value is 30. So to find the range, we do 110 minus 30, and that will give us a value of 80. 80 is our range. For this next data set, let's find the mean, median, mode, and range again. Now remember, for the mean, the first thing that we want to do is to add up all of the numbers. So it does not matter if they're decimals, we're just going to line them up the way that we know how to make sure that we get the correct answer. Now, when you add all of these values together, you should get a total of 41 and 9/10. 41 and 9/10 divided by the amount of numbers we have, which is 9, is approximately 4 and 66/100. So our mean for this problem is 4 and 66/100. For the median, let's put our numbers in order from least to greatest and mark them off from smallest to largest. So as we go through and mark those off, we see that our middle number is 5 and 6/10. That means that our median is 5 and 6/10. To find the mode of our values, we are still going to look at our numbers in order from least to greatest, and we can see that 5 and 6/10 is the only number that is repeated. So our mode is 5 and 6/10. To find the range, we need to find the highest value, which in this data set is 7 and 3/10. And then we need to find the lowest value, which in this data set is 2 and 1/10. Now to find the range, we subtract 7 and 3/10 minus 2 and 1/10. Now when you're solving for your decimals, don't forget to line up your decimals. The answer to this problem is 5 and 2/10. 5 and 2/10 represent our range. In this next data set, let's find the median again by adding up our numbers. We have 71 plus 78 plus 88 plus 72 plus 86 plus 84 plus 84 again plus 85 plus 75 plus 77. That gives us a total value of 800. Now we divide that 800 by the amount of numbers that we have. So 800 divided by 10 is 80. Our mean for this problem is 80. Now let's find the median of our problem by putting our numbers in order. Let's start with 71, then 72, then 75, 77, 78, 84, 84 again, 85, 86, and 88. Now let's mark them off: smallest, largest, smallest, largest, smallest, largest, smallest, largest. And we have two numbers here in the middle in our median, so we have to find the average of those. 78 plus 84 is equal to 162. Now, because we added two numbers, we want to divide by 2, which gives us a value of 81. So 81 would represent our median. Now to find the mode, we're just going to list the numbers out again so that we can find the one that is listed most often. So now that we have relisted all of our numbers in the data set, we can see that 84 appears twice, more than any of the other numbers, so our mode is 84. Now lastly, to find the range, we need to make sure we know what the highest value is, and that value is 88. Then we need to make sure we can find the lowest value. That value is 71. So in order to find the range, we take the highest value, 88, minus the lowest value, 71, and that gives us a total of 17. So that means all of our data set is spread across 17 numbers, and that is our range. Next, let's use what we have learned to construct a box and whisker plot. So we remember for the box and whisker plot, the first thing we need to do is find the median. And in order to find the median, we're going to put our numbers in order from least to greatest. Our least number is 9, and our greatest number is 20. Mark off your lowest number, then your highest, then your lowest, then your highest, then your lowest, highest, lowest, highest, lowest, highest, and you will find that your median is 13. Next, we're going to take this median value and put it on our number line. Now let's look to the left of our median number and find the median of those numbers. That is our lower quartile. So let's begin by writing those numbers out that are to the left of our median. That includes 9, 11, 12, 12, and 12. To find the median of that, we mark off the lowest number, then the highest number, then the lowest, then the highest, and we find that the median of our lower quartile, or our Q1, is equal to 12. Mark that on our number line, and we're going to continue with the values to the right of our median. We have 15, 16, 17, 17, and 20. We're going to mark these off from the lowest, the highest, lowest, highest, and see that our middle value, or our Q3, is 17. Now let's mark that on our number line and draw a box. This is the box of the box and whisker plot. Now, in order to find the whiskers, we need to know what the minimum value is, and that is the lowest number in our data set, which is 9. Next, we need to know our maximum value, which is the largest value in our data set, and that is 20. So now let's draw our whiskers. We have 9 and we have 20, and we're just going to attach that to our box, and voila, a box and whisker plot. Lastly, let's find our interquartile range, which is also our IQR. This is our Q3, which is 17, minus our Q1, which is 12. 17 minus 12 is 5. The IQR for this problem is 5. Jumping right into the next problem, we know that we need to find the median, so we're going to put all of our numbers in order from least to greatest and go through and find the middle numbers. Now in this case, we have two middle numbers, 70 and 80. So we are going to add those two numbers together to give us a total of 150. Now we're going to divide by 2 because we added two numbers together, and that gives us a value of 75. So our median in this example is 75. Now let's mark 75 on our number line. Next, let's find the median of our lower quartile, which is our Q1. Let's list out the numbers in our lower quartile and then mark those off from least to greatest to find that middle number. Now our middle number is 40, so that means our Q1 is equal to 40. Let's mark that on the number line. Next, we want to find the median numbers of our upper quartile, so we list those out, and then we find the middle number by marking those off highest and lowest. We see here that our middle number is 90, so our Q3 is 90, and we can add that to our number line as well. Now that we have that, let's draw our box in. And then we need to decide on the minimum and maximum for our whiskers. So the minimum is 30, and that is our lowest value. Our maximum is 110, and that is our highest value. Now let's draw on our whiskers by adding our lowest value, which is 30, and our highest value, which is 110. Now let's use this information to find our IQR, which is also our interquartile range. We take Q3, which is 90, and Q1, which is 40, and subtract those to give us a total value of 50. So our interquartile range is 50. Next, let's create a box and whisker plot using decimal values. The first thing we need to do is find the median numbers. So that means we put all of our numbers in order from least to greatest and mark off the lowest and the highest until we get to the middle number. 5 6/10 is our middle number, so we call that our median. Now let's mark 5 6/10 on our number line. The next step is to find the median of the lower quartile. So we are going to use all of the numbers below our median to find Q1 value. Remember to mark the numbers off lowest and highest in order to get the middle numbers, which in our case is 2 2/10 and 2 8/10. We are going to add those two numbers together to give us a value of 5. Now we're going to divide that 5 by 2 because we added with two numbers. So our Q1 is 2.5 or 2 5/10. Let's put that number on our number line. Next, let's find the values for our Q3, which is our upper quartile values, and we're going to write those out, and we are going to find the middle number of those values. So here we have two numbers again that we are going to add together. 6 3/10 plus 7 1/10 is going to give us a value of 13 4/10. Now we are going to divide that by 2 because we use two numbers that we added together, and that will give us a total of 6 7/10, which we can now add to our number line as our Q3 value. Now that we have found all of our box values, we're going to make our box on our number line, and then we're going to find our minimum and our maximum to find our whiskers. So our minimum value is 2 1/10, and our maximum value is 7 3/10. When we draw that onto our number line, we can see that now we have a box and whisker plot. The next step is to find the IQR, which is also the interquartile range. We use 6 7/10 minus our Q1, which is 2 5/10, which gives us a value of 4 2/10 as our IQR. So our interquartile range is 4 2/10. As the last problem for our review, let's do one more box and whisker plot. And we remember the first step to doing a box and whisker plot is to find the median. So we are going to list all of the numbers in order from least to greatest, and then we are going to mark those off highest and lowest until we can find the middle number. 71, 88, 72, 86, 75, 85, 77, 84, and that leaves us with two values in the middle. We need to find the mean of those numbers, so 78 plus 84 is equal to 162. Then we're going to divide those numbers by 2 to give us a value of 81. 81 is our median. Let's put 81 on our number line. Next, we're going to find the values of the lower quartile, so we are going to list all of the numbers that are below our median, and then we're going to find the middle of those. 71, 78, 72, 77, and we can see that that middle number is 75. So our Q1 is 75, and we can add that to our number line. Now we find the numbers of our upper quartile, and we list all of the numbers out that are above our median. Now let's mark those out to find the middle. We have 84, 88, 84, 86. So our middle number for our upper quartile is 85. Our Q3 is 85, and we can add that to our number line as well. Now we have the value for our box. We can draw in our box. Now in order to find the whiskers, we have to find the minimum and the maximum. The minimum is our lowest value, and that is 71. And our maximum is our highest value, and that is 88. Now we can add our whiskers to our box and whisker plot. The last step of our box and whisker plot is to find our IQR, or our interquartile range. Now to find this, we use our Q3, which is 85, and we subtract our Q1, which is 75. This gives us a value of 10, so our interquartile range is 10. To help you learn this lesson, I have prepared guided notes to help you organize your thoughts in this lesson. This lesson is a part of a larger unit available at kepcurriculum.com. Each course contains video lessons, guided notes, practice activities, and assessments to help you learn and remember the material. The course, you can reinforce your knowledge and ensure a deeper understanding of the content. It's easy to print the guided notes and use for those offline study sessions. I am Ms. V. Richardson, and I want to say thank you for watching this lesson using guided notes. And don't forget to subscribe to the channel and become a family member at kepcurriculum.com. And don't forget, if you want to extend your learning, here are some additional videos that you can tune into.